With ANSYS AIM, you have a single simulation tool and one user interface to solve many different types of physics, all starting with the same geometry. AIM uses advanced ANSYS technology under the hood to tackle fluid flow, thermal, electromagnetic, and structural simulations, as well as multi-physics problems like thermal-electric or fluid structure interaction. It all starts with AIM's built-in geometry editor, which utilizes the SpaceClaim direct modeling technology. In addition to preparing the geometry for simulation, such as fluid volume extraction, you have the flexibility to manipulate any CAD file. Just click and drag faces to achieve any angle or dimension you want, or add geometry parameters of your choice to enable design exploration in AIM. AIM is physics sensitive and generates a high-quality mesh ready to go with minimal user intervention and designed to deliver accurate results. The default fluids mesh is automatically refined in areas of high curvature. The proximity size function generates the desired number of cells in the thickness of solids or in small gaps. Hex meshes are generated in the bolts to reduce overall model size. Detailed meshes like this take less than 1 minute to create. In contrasting structural simulations, AIM automatically creates a mesh best suited for stress analysis, including high-order elements. For this model, we want to understand fluid, thermal, and structural performance of a flow control device where hot and cold fluid streams mix and are regulated by a butterfly valve. After a quick solve, it's time to view the results. AIM's streamlined user interface makes it easy to select the exact result you want and display multiple results simultaneously if needed. In this example, we're solving for flow and temperature in the fluid and solid domain. For the structural study, we've set up a multi-step simulation with bolt pretension and an applied downward load on the flange. AIM makes it simple to couple physics together, in this case mapping flow forces to the valve and viewing the resulting stresses and exaggerated deformation. Just as easily, AIM can perform a thermal FSI, where temperatures from fluid simulation are mapped to the structural simulation to predict thermal stress. With AIM, results from multiple studies are available at your fingertips and a handy workflows panel. Use AIM's streamlined single user interface for solving multiple or multi-physics simulations, and watch your product development process go to the next level.